Hi everyone. So this is supposed to be a little more fun video, kind of explaining why the bottoms-up method works. You know, I'm really passionate about you not being trained monkeys and just following steps. I want you to be able to understand that things actually have a reason why they work. And so this video kind of shows why the bottoms-up method works. If you remember some of the explorations we did in class with the areas and perimeters of rectangles, one of the other things that we saw was the fact that all quadratic functions with vertical stretches still have the same zeros. As we can see, the a value here is 12. I'm going to rewrite this as another quadratic function with a vertical stretch of 12, which would be 12 times x squared plus 13/12 x minus 4/12. What this means is that the function 12x squared plus 13x minus 4 has the same zeros as the quadratic function x squared plus 13x minus 4/12. As we know, if it's just an x squared and the a value is 1, there's no number in front of the x squared, it's really easy to find the factors based on the products and the sums. So, based on what we know with those relationships, I know that I need two numbers that multiply to negative 4/12 and that add to 13/12. Now, you might be thinking, how in the heck am I supposed to see this with all these fractions? Well, I know when I add two 12ths together that they're going to get 12ths, but I don't know how I'm going to see what happens when I multiply them together. Well, in order to take care of that, if we're looking to have things both be 12ths, well, if I multiply 12ths by 12ths, I'm going to get 144ths. And so in order to, believe it or not, make that easier to see, I'm going to take the negative 4/12 and I'm going to multiply both the numerator and denominator by 12 to make an equivalent fraction out of 144ths. Since negative 4/12 is exactly the same as negative 48 144ths, I now see that this is the exact thing that I've been doing when I multiply the a and the c together. Now, when I look at it with the fractions, the two numbers that I found before that were positive 16 and negative 3, they're actually going to work out perfectly with the fractions when I multiply them together. Negative 3/12 times 16/12 is negative 48 144ths, or negative 4/12, and negative 3/12 plus 16/12 equals 13/12. If nothing else, hopefully that kind of gives you a little bit more of a reason for why you have to multiply the a value and the c value together. All I'm going to do now is just distribute the 12 back into this to get rid of the fractions. And as you'll notice, in order to get me some nice whole numbers, I just multiply 4 to the first factor, and I multiply 3 to the second factor. So there's my 4 times 3 that I can put back together to make 12. And then you'll just notice after I distribute it, 12/12 is 1, 16 times 3, that's 48/12 or 4. And here we are once again with our factored form, 4x minus 1 times 3x plus 4. So not only does this explain what's going on with the bottoms up method and some of these other A times C method. But this is also, if you're okay dealing with the fractions like this is a perfectly legitimate way to factor this as well. And one of the other advantages is it's really easy to pick out what the zeros of the function are. So hopefully I've shed a little bit more light on why the rules work. If I get like 10 views of this, I'll be pretty ecstatic. Maybe some more, but hopefully this was at least kind of interesting and kind of eye-opening to show you the magic behind this set of steps that seems to magically work every time.